Well, students, till now you have learned how to evaluate a determinant through expansion or through simplification of the determinant. We can simplify it first using the properties, and then it can be easily expanded and the resulting expression can be obtained. Today we are going to discuss another utility of the topic determinant. You can see we can use it in order to evaluate the area of triangle as well. In class 10th, you have learned how to find the area of triangle if its vertices are given to us in the chapter coordinate geometry. So see, if A is having coordinates x1, y1, B is having coordinates x2, y2, and C has coordinates x3, y3, then we know area of triangle ABC can be written in this form. Okay, this expression was found by solving, by making a triangle within a Cartesian plane and then using the area of triangle, breaking it into smaller triangles and trapezium, and then evaluating the area of triangle. Okay, this you have learned in class 10th. Now we will try to convert this expression into the form of the determinant. If you see carefully, this is actually expanded form of this determinant which I have written here. Let us quickly see. If I expand this determinant through column 1, okay, and whether we are going to get the same expression or not. So keep in mind, I am expanding it through the first column. So x1 multiplies with this minor determinant, and the value of this is y2 minus y3. So the first term is obtained. Then when we move to the next term, its position is 2, 1. Second row, first column. So obviously this x2 will multiply with minus 1. So I will have minus x2. Okay, so hiding the row corresponding to it and the column. These are the 4 elements we are left with. So let us solve this determinant. It will come out to be y1 minus y3. See, this is y3 minus y1. We are getting y1 minus y3. Moreover, we have minus x2 here. So if that minus be multiplied inside, the inner expression will become y3 minus y1, and it can be converted into exactly this form. Then coming to the third element, which is x3, hiding its row and column. This is the minor determinant left, which on solving gives us y1 minus y2. So the above expression for finding the area of triangle can be expressed in the form of a determinant only. Okay, then some results related to it. We all are aware, if the 3 points are collinear, then area of triangle is 0. So if we know that the 3 points are collinear, obviously on solving this determinant, it will come out to be 0. Then as area is a positive quantity, the absolute value of determinant is taken. See, we are not only solving a determinant. This determinant denotes the area of a triangle. So it cannot be negative. Area cannot be negative. So if you are getting a negative value, you will take its absolute value as the area of the triangle. Okay. Then if area is given, then both positive and negative values of determinant are taken for calculation. Suppose you are told the area of triangle is 30. Okay, so maybe the value of determinant was minus 30 or it was plus 30. But while, as I said, area is a positive quantity, so when we use the term area for the value of determinant, it cannot be negative. So if I am saying area of triangle is 30, that doesn't mean that the determinant on solving came out to be 30 only. Maybe it was 30 or it was minus 30. So therefore, if area is given to you and you have to do some calculation using it, then for the value of determinant, you will take its positive as well as negative value. Taking both, you are going to do the calculation. We'll take example of that type. Then suppose you know 2 points on a line with these coordinates, as you can see here. Then using determinant, also the equation of line which is passing through these 2 points can be solved. You can write it in the form of a determinant where x and y will denote the coordinates of the general point. x1, y1, x2, y2 are the particular points given to you. So if this equation be solved, the equation of the line passing through the 2 points can be obtained. Now I'll quickly take some questions from exercise 4.3. Rest you will be given to practice. Randomly I'll take some questions, like see the first one, question number 1. Second part I am taking. The 3 points are given to us with the coordinates 2, 7, one of the point, second point 1, 1, and the third point 10, 8. So you have to find area of triangle. We can say area of triangle will be half. Now you can use this expression in order to solve the area. So putting the coordinates of the given points here, and the third column as 1, 1, 1. Okay, and you can understand why the third column elements are taken as 1, 1, 1. We all know 1 is a multiplicative identity of, it is a multiplicative. If 1 is multiplied with any of the terms, then its identity does not change. So it is the multiplicative identity, you are aware. So when we expand this determinant, though it can be expanded through any row or column, but when we go for the third column, you will see it is 1 which will multiply with the value of minor determinant. Then again 1 is multiplying, then this also. Okay. So let us expand it. You can go for expanding it directly. If you want to make any two of the elements 0, that can also be done. I'll solve it straight away through row 1. Let us see what we get. This 2 multiplies with 1 minus 8. Then the next term is 7. Because of its position, it multiplies with minus 1. And when I hide its row and column, the leftover value is 1 minus 10. Okay. Then the last part, plus 1. It multiplies with, you will hide the first row and the third column. It multiplies with 8 minus 10. Okay, let us see how much it reduces to. So it is 2 into minus 7. So that makes it minus 14. Next term is minus 7 into minus 9. So it is plus 63. And the last part, minus 2. So it is half of 63 minus 16. You can see on solving this, the value comes out to be positive only. So you will simplify it and then write the area as those many square units. In case this would have come negative, then we would have written area of triangle is absolute value of this or modulus of this, and you will take its positive value. Okay. Then let us take one question on collinearity. Question number 2 is where we have to show that the given points are collinear. I will write down the points in the determinant straight away. The coordinates of first point are A and B plus C. Second point B and C plus A. Third point is having coordinates C and A plus B. Third column 1, 1, 1. So what do we know? We know the points are collinear. So that means the value of this determinant, or we can simply say half the area of triangle obtained will be equal to 0. So should be 0. Okay. So this is to be proved. If I have to show that the given 3 points are collinear, then I need to prove that the area, the value of this determinant comes out to be 0. So we'll quickly simplify the left hand side. I'm going for direct expansion, let us say from first column. So if it is through first column, A multiplies with C plus A into 1, then minus A plus B into 1. So that makes it minus A minus B. Then moving on to the next term B, hiding its row and column, B plus C into 1 comes out to be B plus C. Then minus this A plus B multiplies with 1. Then the third term in the column, it is C, hiding its row and column and solving this minor determinant. It comes out to be B plus C minus A. So you quickly check whether it reduces to 0 or not. Here A and A are getting cancelled out. In this expression it is B which gets eliminated. Here C gets eliminated. I am going to expand the entire thing. So A into C, then minus A into B, then minus B into C, and we get plus BA. This gives us plus C times B and then minus C times A. So this plus AC and minus AC gets eliminated. Minus AB plus AB minus BC plus BC. So it is half times 0, which comes out to be 0. That is the right hand side. Therefore, we can say A, B and C are collinear. Done. Now let us take another question which explains this third point clearly. Question number 3 it is. Let us take first part. There are 3 points given to us, coordinates of 3 vertices. One is k comma 0, then 4 comma 0, and the third one is 0 comma 2. You are being asked to find the value of k so that the area of this triangle is 4 square units. Let me name this point A, this is B, this is C. So we are given area of triangle ABC is equal to 4 square unit. Okay, so because it is area, it cannot be negative, so it is given as 4 square unit. But it is quite possible the determinant which was solved to get the area, that was on solving half of that determinant was reducing to minus 4. So that is what the point explains, that if area is given, then for calculation you take both positive and negative values of the area given to you. So I will write area of triangle which is half times this determinant can be plus 4, it can be minus 4 as well. Okay, substituting the coordinates and then solving the left hand side. Let us expand it through second column. You can see 2 of the elements are 0, so only the third part we need to solve. Okay, its position is 1, 2, which is sum is giving odd, so this multiplies with minus 1, this will multiply with plus 1, this will also multiply with minus 1. So 2 into minus 1 minus 2, and if I hide its row and column, we are left with the term k minus 4. So this is plus minus 4. 2 we can cancel out. So we are left with minus of k minus 4 is equal to plus minus 4. So you simplify both the equations one by one and see the possible values of k. So either minus k plus 4 will be equal to 4, which will imply k is 0, or minus k plus 4 will be equal to minus 4, which will imply minus k is minus 8, or k is equal to 8. So therefore, what is the point A? A is either 0 comma 0 or A is either 8 comma 0. So these are the two possible values of k. In both the cases, when k is either 0 or it is 8, in both the cases the area of triangle will come out to be 4 square unit.